Let's imagine you're planning a trip to Brazil during your summer vacation. You will arrive in São Paulo, but you would like to enjoy the beautiful beaches and cuisine of Rio de Janeiro. You pack your bags, rent a car, and ask yourself the following question. What is the shortest way to travel from São Paulo to Rio? A similar question was asked by Dutch computer scientist Edgar Dijkstra, but instead of Rio and São Paulo, he wondered about the distance between the Dutch cities of Rotterdam and Groningen. The answer to such a question inspired the invention of a very famous algorithm, which is known as Dijkstra's algorithm. According to Dijkstra himself, he designed the algorithm for the shortest path in about 20 minutes, while having a cup of coffee on the terrace of a cafe with his fiancée. This was in 1956, but it was only 3 years later that he published his invention. Now you might be wondering, how does Dijkstra's algorithm work? Okay, but before that, let's start with a brief introduction to graphs. Graphs are data structures used to represent connections between pairs of elements. These elements are called nodes, and they can represent real-life objects, persons, or entities. The connections between nodes are called edges. That said, we can directly apply graphs to real-world scenarios. For example, we could use graphs to model a transportation network where nodes would represent facilities that send or receive products, and edges would represent roads or paths that connect them. We can also classify graphs as undirected or directed. An undirected graph is one in which for every pair of connected nodes you can go from one node to the other in both directions. A directed graph, however, is the one that for every pair of connected nodes you can only go from one node to another in a specific direction. To represent directed edges, we can use arrows instead of simple lines. Graphs can be classified as weighted or unweighted. A weighted graph is a graph whose edges have a weight or cost. The weight of an edge can represent distance, time, or anything that models the connection between the pair of nodes it connects. For example, in the weighted graph below, you can see numbers next to each edge. This number is used to represent the weight of the corresponding edge. Now that we've taken a look at graphs and how they can be classified, it's time to get back to the shortest path algorithm. Dijkstra's algorithm basically starts at the node that you choose, the source node, and it analyzes the graph to find the shortest path between that node and all the other nodes in the graph. The algorithm keeps track of the currently known shortest distance from each node to the source node, and it updates these values if it finds a shorter path. For example, what's the shortest path between nodes A and C? The cost to go directly from A to C is 8, but we can also go from A to B and from B to C. If we do that, the cost would be 5 rather than 8. Once the algorithm finds the shortest path between the source node and another node, that node is marked as visited and added to the path. The process continues until all the nodes in the graph have been added to the path. This way, we have a path that connects the source node to all other nodes following the shortest path possible to reach each node.